The moon. It's not just a big old space rock in the sky. It's actually very influential to pretty much every aspect of life on Earth. First things first, moon specs. No, not that kind. Not that kind either. Let's see. The moon is about 2,159 miles in diameter, making it actually bigger than Pluto. Poor Pluto.
Aww.
It's 27% the size of the Earth, and it takes 27.3 days for it to rotate on its axis, while it's also orbiting the Earth. This is why we only see one side of the moon, but more on that later. Like all other rocky planets, the moon has a rocky mantle about 825 miles thick, made of dense iron and magnesium-rich rocks. Sorry, it is not made out of cheese. Its core is pretty small, probably iron with some sulfur, among other elements. Its crust is 42 miles deep, and the outermost crust is very broken due to impacts from other space bodies like asteroids. There is also no weather on the moon, which means no erosion, so craters that were made thousands of years ago are still on the moon's surface today. The structure of the moon leads scientists to believe that it was once part of the Earth. This theory states that a huge collision tore a chunk off of the Earth, giving the Earth its tilt and its moon. Another theory is that two small moons collided to form one large moon. Either way, we have our moon, and we love it very much. So that thing I said earlier about only seeing one side of the moon? Well, it's true. We only see one side because as the moon orbits the Earth, it rotates on its own axis just as we are rotating on our axis. So it looks like the moon doesn't move, when in reality it just moves in sync with us. As our moon is spinning and twirling about in space, it goes through different phases. Ha! No, not that kind of phase. Anyway, moon phases. The phases are not only caused by the moon's placement in relation to the Earth. As you can see, they are also caused by the amount of sunlight falling on the moon as it is refracted by the Earth. This is the reason for the moon's different color appearance. The dust particles and clouds in the Earth's atmosphere cause different wavelengths of refracted light to reach the moon that make it appear yellow, orange, brown, or red. Now that we know more about the moon itself, let's talk about how it affects us. The first thing people think of when they think of the moon's effects is tides. Now, the gravity of the moon pulls on the Earth, causing sea levels to rise and fall. You may not know that tides also occur in lakes, in the atmosphere, and in the Earth's crust, but with much smaller effects. High tides are when the water bulges up, and low tides are when the water drops. Here's more or less how tides work. When the moon is closest to the Earth, a time called perigee, the moon's gravity causes the water closest to the moon and the water on the opposite side of the Earth to experience high tides. Low tides happen in between the times when the moon is closest to the Earth and in the areas that aren't subject to high tides. Another way the moon affects the Earth is a thing called tidal braking. See, the gravity of the moon actually slows down the Earth's rotation by 2.3 milliseconds per century. Now, as you can imagine, this doesn't really affect us much, but it's still interesting to think about. Because the energy that's lost by the Earth is actually gained by the moon, making the moon move away from us by about 3.8 centimeters a year. Many people think the moon affects humans too, especially the full moon. Now, there isn't much evidence to support this, but scientists actually do take it seriously. So, to recap, we learned about the moon's structure, its phases, and how it affects the Earth. It's a very unique celestial body that is very vital to life on Earth. Plus, it's just pretty. Thank you, and I hope you enjoyed this.